Hello guys, welcome back. In this video I'll explain one of the functionalities I'm adding to Sparrow to improve large table processing, and because this basic approach when you fit large table into a Vision LLM, it doesn't work in all cases because Vision LLM may struggle processing large amount of data and it could start to hallucinate. So the approach, one of the approaches actually that I'm including now into Sparrow, and in the near future I'll update live Sparrow version with this functionality. So one of the approaches is to use multiple steps, and in the first step we would pass document through classical OCR system, get the text, then we would construct the prompt in a certain way to instruct Vision LLM not to rely on its own image processing functionality, but also pay attention to this text that we pass together with the image, and make sure that the output that Vision LLM is producing, it corresponds to the text that was sent with the image. And yeah, this is how it works now in experimental version of Sparrow. This new command line argument precision, and then when we would run it, then in the first step separate process would execute OCR with this image or the document, and in the second step we would send text together with the image to Vision LLM for processing and to get structured output from Vision LLM to be used in the future in the next step. So now if let's say that we would run it, and then first step is being executed and request is sent to OCR. It takes a few seconds and we should get the answer from OCR. Here we get it, and we see that OCR step was executed with 97% confidence. We got 113 regions, and we're using special prompts with spatial separated blocks. So this also helps Vision LLM to process data more efficient and to avoid hallucinations. So we specify the task, and we say that please use this data from OCR as a primary source of data, and if Vision LLM will see some discrepancies with data it gets using the internal data extraction process, then it will use the data that we passed from by ourselves. And this is quite good because it gives us more control over the process, how Vision LLM is producing structured data. So it's not that it's not complete black box anymore, because we can influence Vision LLM by providing our own data. And this is one of the optimizations. This is another optimization I'm working on with the large tables, where I transform original table in a certain way when it is much easier for Vision LLM to extract data. I'll talk about this in my next videos. Okay, so we got back the answer, and we can compare. We got back the structured answer. And if you look here, somewhere on the top, scroll up a bit, you'll see there's a goodwill net reported as expected, then it goes deferred tax assets, other non-current assets, and total non-current assets. And if you scroll down to the bottom, you'll see that total liabilities correctly fetched, and total stakeholders, entities, equity, is correctly fetched, and then we get non-controlling interests with correct numbers, and total Oracle Corporation stockholders equity is also fetched correctly. So often this is not most complex table you would get, but I'm using it for example as example, and some in this case, I'm using Ollama with QN free 30 billion model, and with some other models without OCR processing step, it would fail and it would produce wrong data. In this case, even without OCR step, data would be fetched correctly, but it's more like just for demonstration purposes, I'm showing up how the pipeline works with this OCR step and how the prompt is constructed. Okay, and using separate experimental branch for this functionality. It's not in the main branch of Sparrow. And the separate parameter is passed here as a flag, precision. And then in the code, when we see that precision is being used, then we provide the callback to the Sparrow data library so that all this OCR functionality is implemented outside of the Sparrow data library to keep Sparrow data library generic and to implement all our custom functionality outside of Sparrow data library inside Sparrow pipeline. And then this callback is being sent, I can show you over here. It's being sent just directly to the Sparrow data library, and then Sparrow data library is using callback to execute the function to which this callback points. And the function is defined over here. Process precision data from Sparrow experimental, and Sparrow experimental is another script that which sits inside Sparrow pipeline, and it's completely outside of the Sparrow data generic library, which just calls the callback, and it doesn't execute any custom logic inside the library. So this allows me to keep Sparrow data generic. Okay, we had here process precision data, and this is the callback implementation, right? And over here we call read OCR data in this first step. Then we construct the prompt, and finally we return the prompts back. And then this new prompt is substituting or replacing original generic prompt, in this case because callback is provided, and Sparrow data library then it sends to the Vision LLM this enriched new prompt with hints of the actual data that the client expects to be returned from the response. So, yeah, thanks for watching, and I'm working on this implementation, testing it out, and fixing some minor issues. And I'll also need to update UI part of Sparrow to include option for the user to conditionally select or remove this precision functionality. And once this will be done, I'll update current Sparrow live instance on sparrow.katanaml.io, and you'll be able to test it out with your own documents. So thanks for watching, and see you next time. Bye.